Now we are going to get some more definitions here in section 2.5. So here they come. For a function f of x, we say that f of x is continuous on an interval if it is continuous at every number within that interval. Okay, so this is different from what we saw before because we're talking intervals now. Our previous definition at the start here just defined a function being continuous at a particular number x equals c. Okay, so this one is looking at just one point. Now, yeah, our new definition is looking at an interval if we have continuity at all the points within that interval. Okay, so that's continuous on an interval. Then we could say f of x is continuous from the right okay, continuous from the right at a number a. So we're looking back at a single point here again. So this is true if the limit as x approaches a from the right of f of x equals f of a. So that means the right-hand limit matches up with the function value. Okay, so that's where we have continuous from the right with the right-hand limit. For our next definition, it's going to be the opposite. F of x is continuous from the left at a number a if the limit as x approaches a from the left of f of x equals f of a. So this definition uses the left-hand limit instead. Okay, left-hand limit equals f of a. All right, so we've got continuity on a general interval, and then at a particular point, you could have continuous from the right or continuous from the left. Okay, now we'll look at a little example to help us visualize what this looks like. So we are going to consider the function f of x shown in the graph. All right, it's a very piecewise function. It's got three main pieces here. This piece, this piece, this piece. All right. Various types of discontinuities in here. But what we're going to be looking at is continuity, starting with continuity from the left. So, at what values of x is f only continuous from the left? So, not overall continuity, but only continuous from the left. So, let's kind of look at our main areas here. Okay, so we want to focus in on the points where there might be some trouble. Okay, I would identify those as -3, -1, 2, and 6. Okay, so those are kind of our 4 values that we want to be testing out here. And why did I circle those? It's because that's where the discontinuities are at. Okay, we've got a removable discontinuity right here, a hole in the graph. We've got a jump right here, jumping from one piece to the next. We've got another smaller jump right here. And then we have a removable discontinuity right here with a function value, but the function value didn't fill in the hole. Okay. So we're focusing in on those discontinuous points. So, at what values of x is f only continuous from the left? Well, let's check them. We want to do our left-hand limits. So, get your finger out, and we're going to start with our x equals -3 value here. Put your finger on the function to the left of -3, and we're going to trace along the function, coming in closer and closer, and we see that, well, we do not have continuity from the left there because there is no function value. Remember, our definition for continuous from the left is that our left-hand limit equals f of a. And here there is no f of a to look at. F of -3, excuse me, f of -3 just does not exist. So we can't have continuity from the left there. So let's try our next value, x equals -1. So put your finger on the graph to the left of -1. Come in, approaching x equals -1. And here we do actually end up hitting the value f of -1 because that's where that hole is filled in. Okay, f of -1, that's the solid point. That's where the value actually is. Okay, this is not f of -1 up here. So the fact that our left-hand limit actually equals the function value, that gives us continuity from the left. Okay, so let's put that on here. X equals -1. And just to note here, this is because the limit as x approaches -1 from the left of f of x equals f of -1. Okay, now we can check our other values fairly quickly here. As we look at x equals 2, start to the left, come in with your approach, and we are not going to hit the function value there. F of 2 is right here. F of 2 equals 1. So we did not match up with the function value coming in from the left. So not left-hand continuous there. And then our last point, x equals 6, start to the left and approach. Well, we don't hit a function value. There's kind of no way we could have. The function value is all the way up here. So nope, no left-hand continuity there either. Okay, so it's just x equals -1 for that. All right, now we're going to do the same type of thing from the right. So at what values of x is f only continuous from the right? So you might want to pause your video right now and try it out. See if you can get it. Okay, so you've paused your video and we're back to check where f is continuous from the right. And again, we're going to focus on those 4 different x values where the discontinuities are. Starting with -3, if you start to the right and approach, well, we do not hit a function value because there's no function value to hit. So no continuity from the right there. Looking at x equals -1 now. Starting to the right of -1, notice how that would put us on this piece of the function. Okay, so put your finger up here to the right of x equals -1 and approach. And from this direction, we are approaching the hole in the graph, not the function value. So f of -1 is down here, and our limit does not match up with that. So we do not have continuity from the right there. Okay. Now at x equals 2, will be on this piece of the function that's to the right. Okay, so put your finger on that function to the right of 2 and come in with your approach, approaching from the right. And we do actually have a limit that matches up with the function value. So there's f of 2, and that is what our limit approaches. So we do have continuity from the right there. Let's put that in our answers. X equals 2, because our limit as x approaches 2 from the right of f of x equals f of 2. Okay, both of those values equal 1. So the limit is 1 and the function value is 1. So check, check. All right, last one to check. X equals 6. Start to the right and approach, and we do not approach the function value. We approach the hole in the graph. Function value's up here. So no continuity from the right at 6. Okay, so that means x equals 2 is our only answer for that. All right, so then the third part of this question for this function f of x is to describe the set of x values where the function is continuous using interval notation. All right, and we are going to have quite a few intervals of continuity here. So notice that we have those 4 places where the function is discontinuous. -3, -1, 2, and 6. All right. Everything else in between those values is continuous. All right. So let's change up the highlighter color here. If we're coming in along our function, everything is all good and continuous. It's just like a line up until x equals -3. So that is one good solid interval of continuity. As long as there's no discontinuities in that bit, we would say that interval is continuous. So we could say the function is continuous from -infinity to -3. And we're using interval notation here. All right, so brush up on that if you need to. That's your square brackets and your parentheses type notation. Okay, and the parentheses on here mean we're not including either of those points as having continuity. Okay, and then we'll union that with the next bit of function, which is going to be this piece from -3 to -1, okay? Even though the function takes a steep bend in the middle there, it's still continuous. There aren't any discontinuities between those two x values. So that is our next interval, -3 to -1. And there is a little bit of debate sometimes as to whether or not we should include -1. Sometimes we think one way with rationale, and then my math lab, for instance, says another thing. Since we identified x equals -1 as having continuity from the left, it would be reasonable to put a square bracket on that value and say that, okay, -1 is included as being a continuous point from that direction. Okay, now I would need to brush up a little bit and remind myself what my math lab tells us to do. So if you encounter any issues with that on the homework, let me know and I will try to resolve that for us. Okay, So there's our interval. And then the next one is going to be between the next two discontinuities. Okay, so picking up from -1 and traveling along the function, it's fine, it's continuous all the way up to 2. Okay. Now, we would not include -1 in this interval because we do not have that continuity from the right, only from the left. So we're going -1 to 2 and not including either of those. Okay. And then we'll union again, lots of intervals, like I said. Next continuous bit of function goes from 2 down here through this V shape all the way up to x equals 6. That's all continuous and good. And notice how we do have right-hand continuity, or continuous from the right, at x equals 2. So we could include that in our interval here. So 2 to 6. We would not include 6 though. And then for the very last one, we'll assume that the function keeps going solidly from 6 off to infinity, since they haven't shown us any other discontinuities. So we would say the last part is 6 to infinity. And there we go. So there's 5 different intervals of continuity on this function. It's just split up by those 4 discontinuities.